We are going to start taking a look at graphing quadratic functions. To begin with, we are going to look at the parent function, which is up here, y equals x squared. There's going to be 3 different videos that we are going to look at for graphing quadratics. We are going to look at vertex form, we are going to look at standard form, and then we are also going to look at intercept form. So to begin with, looking at y equals x squared, think about this as if you were going to make a t-chart with it, filling in your x column, picking those x values, and plugging them in and getting your y column out. Again, this is the parent function that will be used when we are working in vertex form. So the parent function deals with the transformation piece like we did in absolute values. So if I make my table, my xy table, I pick my x values. Because it's squaring it, I'm going back and picking negatives and positives. I can do more, I could do less. Generally for quadratics, 5 is a pretty good number to pick. Gives you a nice shape as long as you have those key features. By picking -2, -1, 0, 1, and 2, that'll create your nice parent function. You can see the different things that happen. So -2 squared is 4, -1 squared is 1, 0, 1, and 4. So I'm going to plot those points on my graph. And now that those points are there, I'm going to connect it. All quadratics are nice and U-shaped. So make sure those are nicely U'd. Do not make them look like V's. That's part of the reason the 5 points is a good starting point at least as well, because you will see that they are not just straight lines from there. So that's the parent function of our quadratics. They all should look like that. We're going to slide them around. We're going to flip them upside down. We're going to stretch them. We're going to shrink them, etc. So we're going to start by looking at what's called vertex form. Vertex form is y minus k equals a times the quantity x minus h quantity squared. Now, again, sometimes you like seeing y by itself, y equals form. So just add the k over. Y equals a times the quantity x minus h squared plus k. Both of those are vertex form. It doesn't matter which side that k is on. Keep in mind, if the k is on the left-hand side, it says y minus k. It's the opposite operation. If it's on the right-hand side, it's the same operation because it's plus k. That's something you're going to have to get comfortable with because you're going to see these in different forms. If you get it initially in the first form and you don't like it there, transfer it to the bottom form. Or if you get it in the bottom form, transfer it back up to the top form. Whatever you feel most comfortable with. So this is called vertex form because it automatically gives you your vertex. The vertex is right here. So the vertex for this problem is hk. So if you notice, the h, it says x minus h. It's positive h. X minus h. It's a positive h. And it says plus k. And it's a positive k. That is the value of your vertex. So it is going to be important when you look at your negativities. And I'll make sure I include that when we do some of the problems so that you can kind of see, oh, how does this look as you go along the process. Vertex form instantly tells you your vertex, which is why it's called that form. And then it does transformations with your parent function to find the rest of your points. The vertex piece of it is nice. It gives you a quick check. Yes, I did this correct. However, what I'm going to be looking at is completely through transformations, and I'll double check with my vertex. So in this example, I'm going to start with my parent function. I'm going to start with y equals x squared, and I'm going to make that table, and then we're going to do the transformations. So there's my parent function. That's my table I'm going to look at. So from this table now, I'm going to do what this transformation piece says. The one thing I will do is more so because I feel most comfortable doing this, is I'm going to add the 3 over to the other side. Get it solved for y. That way I can just work in that form, the y equals form. So now I have to look at, just like we did in absolute value, what's attached to x, what's attached to y. What's attached to x is directly related. It's within the set of parentheses. And then what's attached to y is what's outside of those parentheses, outside of that squaring quantity. So what's attached to my x value, it says x plus 1. But if you remember, it's x minus h. So it's the opposite of what's attached to x. So it says x plus 1. Therefore, all of my x values are going to subtract 1. So it was -2, it's now -3, -2, -1, 0, and 1. So all my x values subtract 1. Then I have to look at, well, how is my y value affected? What's attached to my y? Well, if you look at your y value, it's this part that's on the outside. It's that 3, and it says plus 3. Again, very important. What's attached to y, since it's on the opposite side? The opposite operation has already taken place. So I am going to add the 3. The opposite piece has already been done. So I'm adding 3 to all my y values. So 7, 4, 3, 4, 7. So I have all of my entire table that's going to make up my graph. It's those 5 key points. So now what I'm going to do is I'm going to graph those and connect them with nice curves. There is that vertex. It is a quadratic. There is that lowest or highest point if it's flipped down or if it's opening down. So now, because it's in vertex form, it does automatically tell me the vertex. It deals with what's attached to x. It's x minus h. So my vertex is -1 plus k. My y value of my vertex is 3. -1, 3. Sure enough, I did it correct. Vertex was 0, 0. It should shift over perfectly into -1, 3. There was no multiplier in this case, which would affect the stretch and the shrink to it, just like with absolute value. However, in this case, all it was a transformation left 1 unit and up 3 units. One more. Take a moment before you watch me go through this video, before you watch me do this problem, make a list of your parent function. Do your transformations. Keep in mind there is a multiplier, that -3. Just give you a hint in case you forgot. That -3 is your multiplier. Is it attached to your x or your y? It's on the outside of the parentheses. Therefore, it's affecting your y value. Keep in mind we do multiplication before we do addition. So I pulled up my parent function. I'm going to rewrite my equation. So when I look at my x values, what's affecting my x? My x, it says +4, so I do the opposite operation of it, which means I'm going to subtract 4. And then I look at what's affecting my y. As I said beforehand, there's that multiplier of a -3, and it says +2. Since it's on the opposite side of my y, I do the exact operation. So all my y values, all these y's, will be multiplied by -3, and then I'm going to add 2. You kind of think about your order of operations. You do the multiplication piece first before you do the addition and subtraction. So I'll start with the 4. Take 4 times -3 is -12, plus 2 is -10. And it was 1. I multiply it by -3, so I get -3. Plus 2 is -1. It was 0 times -3 is 0, plus 2 is 2. It was 1 times -3 plus 2. And it was 4 times -3 plus 2 is -10. I want you to take a quick peek here. The vertex was at 0, 0. With the transformation, my vertex is now -4, +2. Opposite of x, same as what's attached to your y. So plotting these points and connecting the dots. This time my vertex falls at -4, 2. And that's my highest point in a quadratic. The quadratic always has a highest or lowest point. Connecting my dots, and that is vertex form using transformations. If it is in vertex form, this is the way we do expect you to do it. Going through, getting it rewritten out, making that parent table, and coming up with your final one. The next video that you're going to look at is standard form, and then after that is going to be intercept form.